is Sam Myers. If you've never been to one of our webinars before, I'm one of our trainers. I'm our in-house building science consultant as well. And what you see behind me here is a Flowlab that I built when we were kind of in the beginning of the pandemic. So we're actually going to use this Flowlab test simulator to run a blower door test. And I'll show you how the equipment goes together and then how to get the readings that you need as well. So I've got a second camera here where I can switch back and forth to get close in on the equipment so you can actually see how all the components work together as one system. The way we usually run blower door tests, if you've never seen one before, is we run it from the inside of the house. So we're standing inside. So whenever we get to that point, just assume that I'm standing inside, the other side of the door is outside. So for filming and sharing this with you over a webinar, this is just the easiest way to have everything set up. Gives me room to move around and things like that. So what I usually start with when I do one of these 101 classes is talk a little bit about why we care about this stuff, why we do air tightness tests, why we care about it, and what it can do for us. And then we'll dive in a little bit more into the mechanics of it. So I am going to share my screen here again. So air tightness testing. So the reason why we run these tests, there's several different trades that get into this. The first one that comes to mind for a lot of people is energy auditors. If you're going to do an energy audit, you need to know the air tightness of the building. However, insulators get into this too, because not only do they insulate buildings, they also do a lot of the air sealing that's required too. So what they'll do is if they're coming into an existing building to maybe do some weatherization work, they'll run an air tightness test, do the air sealing, and then run a post test to see how much it dropped and maybe see if there's some spots that they missed that they need to go back and cover. And another thing that we're really seeing a lot of too is HVAC contractors getting into this. When you really think about it, the building envelope is a part of the HVAC system. I've been talking a lot about this lately in some other webinars and some classes that I've taught. And really the building envelope is the container that holds in all that conditioned air that HVAC contractor is working to produce. So we need to know how airtight that is. Is that going to be controllable for comfort or not? So some HVAC companies have gotten into building envelope air sealing. Some of them work with an insulator that might do that. Or they might just simply say, hey, this isn't really an HVAC problem. The mechanical systems look good. This is more of a building envelope problem. So running an air tightness test can help them determine if it's HVAC related or building related, or maybe a mixture of the two. Home builders are getting into this a lot too, especially if they really care about the performance of the home. We see a lot of custom home builders getting into this. Some of them get pretty competitive on how low that they can go, and it just allows them to provide a higher quality product to their customers as well, especially in states where air tightness testing is becoming part of the code. So it's different in different states. Sometimes it's even different in different jurisdictions in the same state. So it's a lot to keep up with. It's a lot for us to keep up with because things are always changing. But some states require this, some don't. More are starting to come online. So it's different depending on where you live. So one thing that we really think of, people think of energy efficiency when they think of air tightness. And yeah, it does help out a lot with that. And that's huge. But some of the non-energy benefits are a lot more intriguing to building owners and occupants, especially the durability of the home. That's a big one, especially in humid climates. I live in the southeastern part of the United States, so it gets very humid here in the summers. And some things that can happen is, if we don't have good insulation, if we have a loose, wall or ceiling assembly or floor, things can start to condense when we start running air conditioning. And most homes are built out of wood. So over time, things can rot. So a lot of the times having an airtight building enclosure can help us avoid that issue down the road. So durability is a big one. Indoor air quality is another one. Again, if we have rotten wood, we can also have mold start to grow for the same reasons. So to really get good control of good IAQ, an airtight building enclosure helps a lot with that. Comfort's a big one. Usually people get these types of tests done If they're not able to sleep well in their own house, usually comfort's going to be a big seller here over energy. People just kind of get used to what they pay in energy bills. They just kind of think, okay, well, that's what it is. That's just how this house is. But really, you can actually bring it down if you work on tightening the house, getting better insulation and things like that. But usually comfort is really the thing that's going to make a homeowner pull the trigger on getting a test like this done. And of course, energy consumption. So looking at the durability of things, this is in a multifamily building, and this is looking between floors. So between floors is a big area of air leakage that usually happens just because that's where some gaps are, two different materials meet, and then warm air can infiltrate there in the summer, condense on cooler surfaces, and then we get stuff like this happening. So that's where that durability really comes into play on how an airtight building envelope can prevent some of this stuff from happening. Same here. If you have this stuff growing, this is in a crawl space. So I'm a big fan of encapsulated crawl spaces for this reason here. So this is in a vented crawl space, mold growth, rot occurring. And then on the floor above that, you're really breathing this stuff in. This air down here eventually makes its way up. So we don't want that to happen. So we want to be able to control that climate a lot better by keeping that outdoor air out, keeping that humidity out, and allow us to control that indoor climate so this stuff doesn't happen. Comfort's a big one. This is actually a historic home. I live in Wilmington, North Carolina. This is in downtown Wilmington. This house was built in the late 1800s. And comfort was, temperatures inside this house were just all over the place. And so this first picture here on the left, you see this is a chimney. And then there's a part of the floor system, the ceiling system there. And then there's this huge gap you can see all the way down. So that's just a massive hole there in the building envelope. And then there's a drop ceiling here on the right. We can see it with a thermal camera. This is in the wintertime. So massive leaks in this house. So we really have to seal this stuff up before we can even start thinking about doing stuff with the mechanicals, because it's really going to change the whole dynamics of the air in here. And it's going to change the load as well. So running a blower door test can tell us the severity of this, and then using a blower door with a thermal imager or a smoke emitter can help us locate where some of these issues are coming from. This is in my own house here. Again, this is in the winter. So depressurizing with a blower door, exaggerating all the leaks in the house, and then I can see that stuff really start coming in with a thermal imager. So this is a bonus room, actually right up there. It's my wife's office. And what we're having to do is go in this is a knee wall. On the other side of this wall is attic. And so there's just not really a good air barrier here at the bottom. So all kinds of outdoor air is able to make its way in. So having to build some scuttles here so we can get in that attic space and seal that up. And so this is kind of where it comes back to why HVAC contractors are starting to care about this too. Because if you're trying to size a new HVAC system for a house, what you really should be doing is what's called a manual J or load calculation. And so this is what the output looks like. This was done in Rcloud. This is for a house that was in Raleigh, North Carolina. And we can see in the heating season, infiltration through the house makes up about a quarter. And we got this, we were able to get this number by running a blower door test and then inputting that number into the software. And so that's going to allow us to be really, really accurate when we're sizing, a heat pump or an air conditioner or a furnace in a house, depending on, where in the country we live. Because, if you know anything about managing moisture in a building, if you oversize a heat pump or the air conditioning, you get this thing called short cycling. So the blower door is able to really allow us to dial that in and get the right size in there. Quality control is a big one too. So, going back to, insulators and home builders that are doing this, we now have an app that we can use with our blower door systems. It's called Rcloud. So you can actually automatically run a blower door test off your phone or off your tablet. And then it automatically generates a report for you. And you can go back and pull it from our server at any time. You just log into your account and see your blower door tests. And so this is where you do like a pre-test, do some work to remediate, tighten it up, do a post test, and you can go back and compare those reports and then show your client how much it dropped, or show the builder how much it dropped, whoever it is that you're working for. So quality control is a big one. So you've heard me use this term air barrier, envelope, pressure boundary is another one. All these are interchangeable terms. This is essentially where that defining point is between inside and outside of the building. So that's what we're measuring the leakage through. So this little graphic here is simulating an existing home that doesn't really have any deliberate air sealing along the building enclosure. So, people look at drywall from the inside and say, well, it doesn't look leaky, but there's actually stuff going on behind the walls that come in through other penetrations that allows outdoor air to come in and indoor air to go out. So running the blower door test allows us to measure the severity of that. And then there's some extra tests we can do to see where these leaks are located. So the duct system, here again in the Southeast, we have a lot of duct systems that are outside of the building envelope. So they might be located in a vented attic like you see here, or they might be located down in a vented crawl space. So those ducts are directly to the outside. So any leakage that's in that duct system is actually a part of the whole building envelope leakage. And then we have lots of other penetrations that go on too. So junction boxes, electrical boxes, ceiling fans, can lights are a big one. Especially in modern homes, we love putting can lights and things. It's just more holes in the ceiling, so it's important to pay attention to deliberately air seal those. But all these places where air can get in, it adds up. And the blower door test tells us how severe all of that is when it's all added together. So I want to talk a little bit about how a blower door works. And I see there's a few chats there in the box. Lee from our tech support team is also on the webinar. So if you have questions as we're going through things, we are going to stop a little bit halfway, and then we'll stop again towards the end and answer any questions you have. So please feel free to use the chat box or the Q&A box. Ask any questions you have. A lot of times Lee can just answer them for you on the fly, but once we get into the demo, feel free to ask your questions there too. We can go back and redo some things and maybe dive a little bit deeper if we have time. But yeah, feel free to use that. So how a blower door works. So anytime we're testing a residential building, we're going to test to 50 pascals of pressure. So take this in for a little bit. This is going to be the nerdiest thing you're going to see all day. If you're a Star Wars fan, you've probably watched The Mandalorian, so you probably know the actor Pedro Pascal. Here you go, 50 pascals. So I got bored and made this during a meeting on Monday. But yeah, 50 pascals of pressure is what we're always going to test to. And that can be positive or negative. And what that means is we can either depressurize the building by pulling air out, or we can flip the fan around and pressurize the building to pump air in. Either one is correct. However, I like to depressurize when I can, because we have dampers along the skin of the building for bath exhaust, kitchen exhaust. So if you pressurize, you're going to blow those open, and your number is usually going to be a little higher. If you depressurize, you're going to pull those shut, and that's leakage you're not going to count. So this is something to think about there. But using that 50 pascal pressure target, this allows us to put every house or dwelling that we test on an even playing field. So essentially what we're doing is we're just exaggerating the leaks in the building. We're getting the entire house under that pressure to that 50 pascal. So in this example here, we're depressurizing. So we're getting the inside of the house to negative 50 pascals. So right along the border on the outside is plus 50, where that air is coming in. And then, if you step away from the house some, we have 0. And I'll talk a little bit about this later. But this is essentially what we're doing to the house. And so that negative 50 pascal pressure is about the same as a 20 mile an hour wind hitting all 6 sides of the house, all 4 walls, ceiling, and floor. So it's pretty strong. To give you an idea, if you know how much an inch of water is, if you're an HVAC contractor, there's 250 pascals in 1 inch of water. So it may not seem like a whole lot of pressure, but when you're applying that to the whole house, it gives us a nice way to control and manipulate the pressure in that house so we can really see how it's leaking. So just a little diagram here to show what's going on. So everywhere we have a leak, through those can lights that I was talking about before, ceiling fans, the duct system, around windows, doors, we're exaggerating all of that, and we're able to quantify the leakage that way. And as I mentioned before, you can test in either direction. You can pressurize or depressurize. So it's important to know when to do which one. If you're testing an existing house that has a wood-burning fireplace, you really want to go check that out. If it has ashes in it and you go and depressurize that house to negative 50 pascals, chances are you're going to pull those ashes into the living room and make a mess. So you either want to pressurize in that scenario, or the best thing to do is just make sure those ashes are cleaned out. And then once it's cleaned out, dampen it so you don't pull any dust or blow any dust around. But that's a big one. A lot of us have done that before. I'm definitely guilty of it. So it's really important to check that house out. And while I'm on the topic too, before you set up any of this equipment, there's some things you want to do to set up the house first. So checking the fireplace is an important one. You also want to make sure that any combustion appliances are set to off or pilot. You don't want to backdraft a gas water heater or a furnace or something like that. And then you also want to make sure that all your mechanicals are off. The only thing that you want manipulating pressure inside of that building is the blower door. So exhaust fans, dryers, ventilation systems, you want to make sure all of those are set to off. And of course, you want to make sure that all of your windows and exterior doors are shut and latched. You don't want anything blowing open. And you want to make sure all of your interior doors are open. So those interior doors kind of behave like dampers. Again, we want to get that entire house to that 50 pascal or negative 50 pascal pressure target. So you don't want to close off any sections of the house to where it doesn't get under that pressure. So open up all the interior doors so that the whole house can be under that uniform pressure of 50 pascals there. So we have some other, some pretty good tutorial videos that walk you through this on our YouTube channel. So feel free to go check those out. It's just really a step-by-step guide on what to look at when you're setting this up before you really start setting up the equipment. So, when you get a few of these under your belt, running a blower door test, you can do it in 10 to 15 minutes. The really time-consuming part is just checking the house out. And that just depends on how big the house is. So you want to check every window, every exterior door, fireplaces, your mechanicals, anything that uses gas, things like that, to make sure that house is going to be ready to go. And, if you're a HERS rater or if you're new to that, really go through and get familiar with the ResNet 380 standards. There's some really good lists in there of things to check for, different types of ventilation and things like that. So that's a good standard to get familiar with to really see how things should be set up before you run a blower door. So what I'm going to do now, instead of just kind of going over this slide, I'm actually just going to show it to you in the blower door that I have set up here, just to explain how this all works. So there we go. You guys should be able to see kind of a head-on view of this blower door system I have set up. So we'll start with the fan. I'm going to shrink this down so we can really get down there and get a good look at it. I'm going to pull this off here. So before I pull this off, what you see here, you'll notice there's some different holes that can be opened and closed. We call these ranges. This plate pulls off. This is ring A. And this is the B8 plate. B is what comes after A, and it has 8 holes, so we call it B8. What is going to determine which range you have it set to all depends on how tight that house is. So the tighter the house, the smaller the opening will be in the fan. The leakier the house, the larger the opening will be in the fan. It's all about being able to maintain the right enough fan pressure in here while being able to hit that 50 pascal target. So you really want to find that sweet spot. You can kind of think of it as like gears in a car. You want to find the right gear to make the engine work, to find the right speed. So it's kind of similar here. If I'm testing a house that I've never been to before, if it's an existing home, I usually start at ring A right here. And then the manometer will tell me if I need to go up. I can open this all the way up and have the fan open by taking this off, or I can go down by putting the V8 plate on and then opening all the holes up to the V8 setting or shrinking it down some more. So the gauge can actually tell me which direction that I need to go if I'm not getting the reading that I need to get for reading A. And we'll do that. I'll show you an example here in just a second. But the way this works is you've got your manometer, which is this right here. And it's what's called a 2-channel manometer. So it's 2 channels because it's actually 2 manometers built into one housing. You've got channel A and channel B. Channel A has this red tube that's coming in that plugs into the red cloth. On the other side of this cloth, there's some tubes that are just reading pressure on the outside. So channel A is what's telling it, lets us know when the house has reached that 50 Pascal pressure target. Channel B has this yellow tube that has goes to the yellow fan here. So channel B is reading the fan pressure. So when we're trying to determine flow, the way that we record flow, I told you earlier, we test houses to 50 pascals of pressure. That's CFM, cubic feet per minute, at 50 pascals. So that's our flow reading. And the way we're able to do that is fan pressure is read at these 4 taps and averaged together. And then the manometer reads it here on the side where this where this yellow tube plugs in. So if we know fan pressure, which we do, we're collecting it here, and we know the area of the inlet of the hole in the inlet side of the fan, which we do, it's programmed into the manometer, then we can calculate flow, and the manometer does it all for us. Back in the day, we had to do this stuff by hand. There's a lot of math using the old school magnet helix gauges. But nowadays, these manometers are kind of like little computers that do all the math for us. So it's we've basically gone from a manual transmission to an automatic. There's really not a lot of extra stuff we need to do to get the reading that we want. So it's always important to make sure that these holes are clear. We've got some videos on our YouTube channel to show you how to ensure that everything is opened up and clear the way it should be, the way it can out of the factory. So that's how we get our flow reading. It does all the math for us. As long as we know those 2 things, the fan pressure and then the fan opening. So going back to the cloth, if we plug that red tube in right here. If you use another manufacturer, blower door, or one of our older ones, this red tube actually has to go through the bottom of the cloth and then at least 5 feet away from the fan opening. We made this a few years ago just to make it easier, so you don't have to actually crawl through the hole and set it somewhere. It's going to be in the same spot every time, and you can just plug it right up to the cloth. So that's what the smart cloth is here. And it actually helps with wind dampening too. So there's a tube here on the outside, and then there's another one towards the top there. So having it broken up like that helps break up the wind when it's blowing outside, so it doesn't screw around with our reading as much. So we'll go ahead and do a practice run of a blower door test now. Let me you've seen how it all sets up, and let me talk a little bit more about how it sets into the doorway. Do we have any questions in the box yet?
Yeah, there's a question about what app you were referring to earlier in the video. Near the start, I was reading a question, so I didn't catch what you had said.
Yeah, I was probably talking about the Rcloud app. It's on, if you use Apple or Android, it's in both the Apple Store and on Google Play. It's just Rcloud, and that's our automated testing app. So we invented that process. It's probably been 7 or 8 years ago for doing automated tests using an app. So yeah, it's at this moment it's free to use, so you can download it and create an account, and it allows you to pair your phone or your tablet with your DM32 manometer, which is our gauge that we're using for our blower door. That's the DM32. It has a Wi-Fi antenna in it, so you can wirelessly attach it to your phone or your tablet, and then you can use that app with it. So we're not going to really dive too much into Rcloud today. That's kind of a little bit beyond the 101 talk. This is just kind of basic mechanics, but yeah, it's out there. It's free. Download it and try it out. So,
all right, cool. And the only other question was if we plan to release the fantastic software for Mac, which I don't believe we have plans for at the moment.
Yeah, cool. Thanks, Lee. Yeah, so obviously you can see that this blower door is already installed, but let's talk a little bit about how that comes together. What you see here is this is an aluminum frame that comes in 4 pieces. So when you have it assembled, it looks like this. So let's see if we can get, yeah. I think you can see, yeah. So all you do is match up the numbers in the corner. So there's a 1, and then there's a 1 here. You just match them up. And there's a rubber seal that goes all the way around the edge. So you get a good tight fit into the doorway. And then there's these, you can slide it apart. So to get it into the doorway that way. And so you just go all the way around to all 4 corners, loosen it up, expand it into the doorway. And then you can tighten everything down. And once it's tightened down, you can flip these to tighten it even more, just to give you good stability into the doorway. And then you can see on this system here, we've got 2 crossbars. So we have 1 here that locks into place just like the other 4 do, and the fan hangs from that. And then we have another one towards the top just to give you more stability. And then the back of the DM32 has a belt clip, and then there's a pocket here that just hangs from. So it just allows you to keep it off the floor. So I'll pull that DM32 down again. But before I put this frame away, to take it apart, you can just stand it like this and just slide it over like that, and it all comes apart in one motion. So back in the day, or with other manufacturers, you have to unhook each side one by one, and it takes a little while. With this one, it just snaps apart in one motion. So that's the blower door frame. And then to put the cloth on, there's a couple ways you can do it. I just like to lie the frame down on the ground. You take the cloth, spread it out on the ground, and then there's these Velcro tabs. You lay the frame on top of the cloth, and then you just kind of go around and wrap it like a present. And then you just set the whole thing back into the doorway, put your crossbars in, and then the cloth has this elastic hole here that the fan just slides into. And then on this bottom crossbar is a Velcro strap here that you just allow it to hang from there. So like I said, once you've done it a couple of times, you can have one of these set up in about 10 to 15 minutes. So the setup time is not very long. But again, we've got some really detailed videos on our YouTube channel that'll really walk you through step by step how this all comes together. Let me bring you back over here towards the gauge so you can see how everything hooks up there. On the fan, let's see here, so you can really get a look here. You can see that yellow port where that yellow tube plugs into. That exact same port is on the gauge itself. So if I take this down, you can see that the ports are color coded. So this is about as easy as we can make it. Yellow to yellow, red to red. And this is unique to Retrotec. No other manufacturer has their setup like this. And then we have a data cable. It's a Cat5 cable, Ethernet cable. This allows the gauge to control the fan. So instead of having to manually turn a dial on the fan, I can just tell the gauge what pressure I want to go to, 50 pascals, and it will take the house there automatically. So yeah, as far as setting everything up, it's you're matching colors together, and that's basically it. So it's pretty easy. So let me get you up so you can see the gauge again a little more clearly. And actually, before I go through it on this, I'm going to share my screen again and pull up a simulator so you can just get a better view of the gauge. Oh, and you guys might be a little confused too here. You see my 50 Pascal decal. There's a 75 one also. 75 is for commercial buildings. 50 is for residential. So yeah, we test all commercial buildings to a higher pressure just to fight stack effect and things like that. And then yeah, 50 for residential. And if you're doing duct tests for the duct tester, it's 25. So those are really the 3 target pressures that we use in this industry for air tightness test. So let me share my screen again. Pull this up. Okay, you should be able to see this DM32 simulator. This is actually a software program you can download for free from Retrotec. It's called Virtual Gauge. And it's really a good teaching tool. So if you wanted to blow up the screen of the gauge and teach some classes or just kind of go through things with your team, you can do that on a projector. It's really nice. We use it for that all the time. But I'm just going to go over just the basic things here to really pay attention to. I talked about the 2-channel gauge before. Channel A is located here. Again, that's reading our building pressure. So our 50 pascals, and whenever we get there, it's shown here on the top. The reading from channel B is shown here. That's our flow. So that's CFM when we get to that 50 pascals. And then here is, we want to make sure that we have the right fan selected and then we have the right range selected. So this is where I'll go do that. So this is a touchscreen gauge. So if I tap on a picture of the fan, that's where I go and select my range. So whenever I select this, let's just say I'm going to go to range B2. I want to make sure that the fan looks exactly like that. Those are the 2 holes that I want to have open, no other 2, mainly because that's how the fan was calibrated when it came out of the factory. So it's important to make sure that you match it up the same way as you see on the picture of the gauge. And then under here, I can go to change device. And so if I have an older fan or one of our high-powered fans, this is just how I can go and select the right fan that I'm using. I can cycle through. There's our duct testers. So residential duct testers, the current one, the previous ones, and then our commercial duct testers as well. We also run our competitors' products. So their duct blaster, their blower doors, their exhaust fan, flow meter. So the DM32 gauge can actually run all of their stuff too. And then you can actually make your own exhaust fan flow meter out of a box. But what's not in this simulator is our own exhaust fan flow meter. It's called the Flow Box. And so it doesn't have any moving parts. It uses the same range plugs as our blower door. So that's also in the newest firmware update of the DM32. So if you buy one new, it should be in there. If you don't have it on yours currently, download the DM32 configurator from our website and you can update the firmware that way. And then it should show up. But we're going to use the Model 5000 blower door today. So that's our basic fan that we use for residential tests. The Model 6000 is a higher powered fan that we use. And, some residential people do it if they deal with a lot of like big historic homes and things like that. But usually for residential purposes, the 5000 will cover all your needs. I'll put it on that ring A setting there. One thing that I can do, if I want to change my output here, if you open up your gauge and it's on something weird, I can just tap on channel B. I can read pressure on channel B2 if I wanted to. I can read air changes per hour. So most codes are going to require air changes per hour, and you really just need to know the volume of the space to do that. So I can actually input that. If I go into settings, I can input volume here, and then it'll give me air changes per hour automatically. So if I go to settings, let's just say my volume is 10,000 cubic feet. It's set. And I can just tap on channel B and choose ACH. And then there, I see that displayed there. So you can just tap on channel B to change it back to whatever you want. So that way you're not having to dig around through the settings menu. It's just a nice little shortcut that we put in there. And then if you remember the old iPhones that used to have a button at the bottom, you could use to tap the home button to go back to your home screen. We did the same thing with our power button. So you can just tap power to go back to your home screen here. And then when I go to run a test, once I have everything set up, if this is the range I'm going to use with the correct fan, I've got pascals on channel A, CFM on channel B. I just go here to set pressure and it pulls up this keypad. So 50 pascals, hit set, and then off it runs. So this is just a fake simulated test. I have it in simulator mode. So almost 2,900 CFM 50 would be the result that I would report there. And if I wanted to change that to air changes per hour, I can just change it. that's actually a really leaky house. 17 ACH 50. That's like a barn with the door open. Most codes require anywhere from like 3 to 7 ACH 50. But yeah, when you're getting up to 17, yeah, make sure all your windows are shut. If they are, then yeah, there should be some big holes you should be able to find. But there's lots of other metrics you can look at too. Equivalent leakage area in square inches. You can actually have the gauge calculate how big the hole is in square inches. So that's another thing that you can do. So like 300 square inch hole here. So that's not really required by any codes or standards or anything. Usually this is used just to show, if you get that number, you can actually draw the hole size out and show the homeowner like, hey, this, with everything added up, this is the size hole we're looking for. But that's usually what that's used for, just to kind of give a visual aspect of how leaky that house is if you wanted to do that. But yeah, CM50 is that's usually our basic way of reporting air leakage here. And one thing that I do OAM to stop the test is hit stop. But before I just go ahead and crank it up to 50 pascals, if it's a house I've never been to before and I'm not 100% sure of what to expect, when I get a set pressure, I'll start at a lower pressure, like 25, and then hit set from there. And then I just want to walk around and then make sure that, nothing weird is going on. I'm not smelling anything burning from a fireplace, or if I'm smelling any mold, that's another thing where I might want to flip that fan around and pressurize the house, because I don't want to bring those mold spores inside. I want to push them out. And then one thing that I forgot to mention before when we're doing our house checks is the only time where Retrotec recommends not doing a blower door test at all is if you have vermiculite insulation up in the attic. So this is going to be for older houses that were built, from the 40s, I think through the 80s, might be from when they use that stuff. Basically, vermiculite insulation has asbestos in it. And no matter which way that you're testing, even if you pressurize, you can disturb that insulation and then it can settle back down into the wall and get into the living space. People argue that, well, yeah, 50 pascals is a 20-mile-an-hour wind. Houses, experience that all the time. Yeah, but why? Our way of looking at it is, why put yourself at risk? So there's actually a trust out of Charleston, South Carolina, called I think it's the Zonolite Attic Insulation Trust. Zonolite was a brand that made that vermiculite stuff. And a lot of times you can get some help with funding for abatement for that. So if you do weatherization or insulation, that's a good group to know if you run into that kind of thing. But yeah, I wouldn't run a blower door test on a house with someone living there if it has that stuff in there. And it kind of looks like a crushed up gray denim. We have an article about it and that trust on our website. If you dig through our blog, Ben Walker, one of our CEOs, wrote it up a couple of years ago. So you should be able to go on our website and find that for more information on that. But yeah, that's just another one of those things just to check for in existing homes where, that's usually the only instance where we say, don't run the fan. So I'm going to stop sharing now, and we'll actually run a blower door test on this chamber so you can really see what things look like. Once we have our blower door set up here, and everything looks good, we've done our checks, all the windows are shut, all the exterior doors are shut, mechanicals are off, the combustion appliances are set to pilot. There's no scary stuff in the attic. Then we're ready. So the first thing that we want to do is what's called a baseline. I talked about wind earlier. Any kind of activity that is happening to the house, like wind or stack effects, we don't want to count that in the equation when we run our blower door test. So we do what's called a baseline reading. We let the gauge read the outside conditions for a little while, and any differences between inside and outside, it'll remove that from the equation. So let me show you what that looks like. And before we do that, we want to make sure that the fan is covered up. So right now it's open. So each fan comes with this shower cap cover. So I'll go ahead and put that on. You can also use the B8 plate with everything plugged up. So if I had the other 2 plugs in here, I can use that. But just to make things a little bit quicker, we have this. Oh, and our cloth too. These pockets are great. Use them. Put your range plugs in there. Just keep stuff off the floor. Keep things from getting lost and stepped on. So that's why we have that built in. But we'll cover the fan up like this. And now we're ready to do a baseline test. So let me walk you over here to the gauge again. I wanted to show you the gauge using the simulator first because things could get a little blurry. These webcams can only focus but so much when you get onto something like this, but that doesn't look too bad. So what I'll do is I'll go into settings, and the first option on the top is baseline. So I'll select that and then capture baseline. And then it's going to start counting down. You see the duration. Hopefully it shows up on your end, but yeah, it's counting down. If it's a relatively calm day, I'll let it count down for about 30 seconds. If it's a windier day, I might let it run for a minute or maybe a little longer. But I can see here, and obviously this is a chamber inside of a room, so it's really not going to pick much up, not pick up a whole lot of anything. 0.1 Pascal is what it has right now. But so we're at 30 seconds now, so I'll just hit end capture. And then I can just, again, tap the power button to go home. And now I can see right under where it says 0.2, it says Pascal of 0.1 baseline. So I can actually see that baseline there for what it collected. Another thing that I want to change here, I'm using a Model 5000 fan. So I want to change that device. There it is. And we'll start off with ring A, just like I talked about before. So we'll uncover the fan. And we take this and put it back in our pocket here. So our fan, we're on ring A. It matches our gauge. It's ring A, that's really important. And like I mentioned before, to get our reading that we want, we can just go to set pressure, 25. Again, I want to start at 25 and then walk around and then just, make sure nothing's getting disturbed, or I'm not noticing any funky smells or anything like that. Sometimes if you test homes that haven't been occupied for a while, the P-traps for the sinks or the washing machines or whatever, or don't have any water in them, so you're just pulling in sewer gas. If that happens, you'll know it immediately. It smells awful. That's happened to me a few times. So yeah, just make sure you have water in the P-traps. You can just run a little bit, fill it up. But that's another thing you might come across if you're depressurizing a house. But yeah, I'll just set to 25 and it's set. The fan's going to crank up. So it's dropping from that 30 down to 25. And let's say I walk around, everything looks good. So I can either stop the test and then re-enter 50 pascals. Or I've got these buttons on the side here. You see these green buttons on the left and right of stop. These allow me to jog it up by 50 pascals. So I can just jog it up. Now I'm targeting 30. You may not be able to see it, but it says seeking value of 30 pascals. And I'll just keep jogging it up until it says 50. There we go. Now you'll notice that we're pretty much here at 50 pascals, but we're not getting anything. I want a flow here. I want a number here. And it's just giving me 2 dashes. And what that means is our opening, that ring A, is too big. I need to choke the fan down to a smaller range so that I can actually get a reading. The blades just aren't spinning fast enough when the house is at 50 pascals of pressure to give me a flow. So I can stop the test. And then, the fan wasn't running very fast. The next step would be B8. So we'll try that. We'll go down to B8. And then what I'll do, back you up here so you can see what's going on. I'll pick up the B8 plate. And so B8 is the plate on with all the plugs out. So I've got all 8 holes open. So that's going to be the next size down. Again, using these pockets here so I don't lose anything or step on anything. Keep everything all organized and together. And this is magnetic. I want to make sure the logo is right side up. It sticks on like that. I've got my gauge set to B8. So get it to where you guys can see that. Try to get that glare off of it a little bit. Here we go. So we'll go ahead and crank her back up to 50 again and see what we get. Now we're starting to get a number. So about 1,000 CF at 50 is how I report this. And again, if I wanted to do air changes per hour at 50, I can go into settings, check my volume. I tested a really large building last time I used this, so we'll put this in something more realistic. We'll do swing, 2, 3, set. We'll change it to ACH. So 3 ACH 50 is how I would report this. With a house that size, with a 20,000 cubic foot volume at 50 pascals. Then I can just tap channel B again and go back to CFM at 50 pascals. So about a little over 1,000, 1,020 CF at 50. Now, to demonstrate what would happen if I'm too low, we'll stop the fan again. I'm going to change the range to B2. And then on the fan, I'm going to make that match. This is, I want to show you this because this is what happens. I want you to see what it looks like whenever you can't get to your target pressure and you need to do the opposite of what we just did. Our fan was too open before. So now it's going to be too, we're going to have that hole opening on the inlet side of the fan too small. And this is how the gauge lets you know where you need to go. So if it's too open, it gives you those 2 dashes on channel B. We're on B2 here. Do our set pressure to 50. Really hear that fan starting to crank on down. So that's when the gauge is telling us, hey, I'm going as fast as I can and I can't get to 50, open it up. So if you can't get to 50, open the fan up. If you can get to 50 and you're getting these 2 dashes, choke it off some more. That's how the gauge tells you which range you need to be using to get the reading that you need. And that's how you run a blower door test. And that's just what we call a single point test. So we're just running the test to 50 pascals of pressure. And that's it. And so we can do this manually like this, or we can use that Rcloud app that I was telling you about before to let it collect that data automatically and then save it in a report. So Lee, I'm going to go back to you and see if we have any questions.
Yeah, looks like we got a few here. So okay. Do you have any tools or procedures for measuring like vaulted ceiling areas? If you're looking for an air change rate and you're trying to measure ceiling space, any recommendations?
Yeah, I like to use a laser distance measurer. There's some different stuff out there. I've got one made by Bosch that'll actually record and draw stuff out for you. That's a quick and easy way to measure vaulted ceilings. So if you're standing in a living room and you want to see what that highest point is, and you want to stand over to the edge and see what the low point is to calculate the volume of that triangle above that cube that you're standing in. That's a nice and easy way to do it without having to get a ladder and a tape measure and all that. So yeah, the laser distance measurers are really nice for that. If you have plans to go by, there's some different software out there that you can use. A free one that's pretty easy is Foxit PDF. That's Foxit. And they have a scalable drawing tool built into that. So you can import your plans into that. And then you can actually draw measurements that may not be there to scale to easily calculate what that might be. So it's always nice if you have plans. That way you can just go by those measurements that are there. But if you don't, yeah, the laser distance measurer is going to be your best friend there.
Yeah, definitely. And break it up into pieces if you can. You can do like the main living space as a cube and then add like prism volumes to that.
Yeah.
As much as you can break it up, that definitely simplifies things.
Same thing for encapsulated attics. If you've got a spray foamed attic where that attic area is encapsulated and actually a part of that condition volume of the house. And yeah, your laser distance measurer is going to be good for that too, to calculate that prism that you'll add on top of the rectangle or the cube that it sits on. Yeah.
Another question, which I guess relates more to using software and not just the gauge testing alone, but how does utilizing environmental conditions, like putting in temperature, barometric pressure, wind speed, how is that going to affect the end result of a test? And I mean, should we test without it and then retest with it if it fails, or what would you recommend?
Yeah, so your air density is going to be different at different elevations and at different temperatures. So if you're in Colorado and you're testing at a super high elevation, your air density is going to be different than at sea level. So we have corrections for that. There's charts out there for that. But if you're using the Rcloud app, what it will do is geolocate where you are and automatically fix all that for you. So you don't need to do any corrections. That's one thing that's really nice about that app, is that you don't have to make any corrections for that. If you use our Fantastic software, which is on the laptop, you can also input that stuff there too to let it do the math for you. Otherwise, if you're just doing just a manual test like I just did here, then you're going to need to apply those correction factors off the table, which we have. But just use the Rcloud app. Let it do it for you. But if you don't apply those corrections, I mean, it just depends on maybe how cold it gets or what your elevation is. It all depends on the extremities of that will depend on how far you're going to be off.
Perfect. Okay. Let me see. There are some other questions. It looks like a few of these I can answer in the chat. Yeah, let's move on for now, and then I might have some more later on.
Okay. Well, we're getting kind of close to the end. We got about 5 minutes left. So one thing that, since we do have a few minutes left, I want to just talk about some of this technology is going to be changing. We've already announced the DM32X will be rolling out in the near future. And so I just want to show you what that's going to look like. Let's see here. Yeah. Share. So, the DM32X is going to be the next blower door manometer that'll be rolling out, likely towards the end of this year or towards early next year, and it's going to be built on an Android platform. And one of the cool things about it is, if you're a beginner, we'll actually have some resources built in so the gauge can teach you what to do. So all of the user manuals and the quick guide manuals will be built into the gauge itself. So like for blower door, I can go read the manual right off the gauge. It'll have a 1080p OLED display that'll be easy to read. The quick guides will be built in here. So if I'm using a Model 5000, I can actually pull that up. And then if I just need a quick refresher of how to set stuff up, I can actually see that on the gauge itself. And we'll actually have some training videos built in too. So if it's my first time out in the field and I just need to see how things go together, I can just watch the video and then copy that. Same thing for our duct testers, the flow box. We'll have how-tos on how to use all of this stuff. And then I mentioned the Rcloud app before. You have to pair your DM32 with a phone or a tablet. We're actually going to have that built into the gauge itself, so you don't have to do that. You can just run automated tests straight off of the gauge. So that'll be built in as well. But the gauge itself will be an app built in. So just kind of clean things up a little bit. You got some photorealistic photos of the fan, the different ranges you can select. And then one cool thing too about this, if you see this word bias pressure and baseline pressure are the same thing. They're just interchangeable terms. So that's how you'll take your baseline on the gauge. You won't have to go into settings. You'll just click that button. And it's actually, you'll see a graphic display. So I can hit this record button and then it'll start recording that baseline there for me. If there's some crazy wind, and see if I play with one of the ports here. Yeah, I can see what that wind is doing to the reading there. And then I can just hit stop if I'm finished recording, yes. And then I can go back and then see that baseline there on my home screen. So, and anytime I want to see a graphic display of whatever I'm reading, I can see it here. I can have a line to show the average of what's going on. I can also turn that off. If I want to see a graphic display of what's happening on channel B, I can look at that too. So yeah, having that live graph on there is going to be pretty handy for some other different diagnostics and things like that. But yeah, so I can also, if I want to just crank up fan speed, if I want to use like a thermal imager or a smoke emitter and just kind of crank things up, I can do it like that. And there's an indicator here to show me that the fan should be running. So if that's spinning and the fan's not on and running, then that tells me I probably don't have something plugged in that should be. And one thing that I didn't talk about that's on the DM32 now is the app feature. So if I go to, let's see here, if I go to set pressure and go to, I've got these hotkeys in here, so I don't have to type in 50 if I don't want to. I can just have it saved in here. Like I said, these are the 3 pressures that we use in our industry: ducts, residential, and commercial. If I want to go to 50, there's this button that has at on it, and this is on the DM32. You probably saw it earlier. I just forgot to mention it. So if I'm running the fan wide open and it is maxed out and I'm almost at 50, but not quite there, I can use this at button here. It'll extrapolate the reading to tell me what that flow would be if it could reach 50. So, if you're only getting like 20, if you're only getting the house at 20 pascals running all the way open, it's a crazy leaky building. Yeah, it's not going to be super accurate, but if you're upwards to like 35 pascals or 40, then yeah, you can use that and trust the reading that you get. So, yeah, that's on the current DM32 now, but we do have it on the DM32X that'll be coming out too. So, yeah, I just wanted to run through this. Myself, one of our co-CEOs, Ben Walker, we're going to do a webinar coming somewhat in the near future whenever we're getting a little bit closer to launch, and go through a much more detailed webinar to show what this thing can do. So, since I just had a few minutes left there, I figured I'd introduce it to you since it is going to be coming pretty soon. So we've got a couple of videos on our YouTube channel for the DM32X where we walk through it a little bit. So feel free to go check those out. But yeah, that's just some of the newer technology that we have that's going to be coming on board here pretty soon. It'll have long range Bluetooth as well, so you don't have to use the Wi-Fi. You can get longer range out of it. If you want to use it to pair with your phone to control the fan remotely, we have an app that does that now called Gauge Remote, but you're only limited to that Wi-Fi distance. With this, you'll get a lot more range out of it if you're in a larger house or going further away from the fan, like up in an attic or something like that. So that'll be pretty helpful there. So, but yeah, that's just a quick and dirty of the DM32X that will be rolling out here in the near future. Lee, do we have any more questions trickle in?
Yeah, let me see. So the one that I couldn't answer up to this point would be a comment about 50 Pascal lifting ceiling tiles from the grid. And would you always pull a vacuum on a room with a drop ceiling, or how would you approach that?
Well, hopefully the drop ceiling is not your air barrier. Hopefully the true structural ceiling above that is. So yeah, I would pull some ceiling tiles out so that we can allow the space above that drop ceiling to also get to 50 pascals. That way they're connected. And if you're pressurizing, sometimes you can actually blow some of those out with the fan. We've seen that happen before. So it's good to just go ahead and pull some of those to allow those two spaces to be connected to each other.
Okay, perfect. Let's see. There's someone asking about roughly how much square footage or volume could a single fan cover. I just commented the kind of a quick check, which is you can do your total volume times your air change rate and then divide that by 60, and then it'll tell you your CFM that you need. Do you know of a recommended square footage per fan?
Yeah, that's you really can't look at it like that. I mean, I've tested houses that are 20,000 square feet, like huge houses with one fan. And I've tested houses that were 2,000 square feet where I've needed two. It just depends on how airtight or how leaky the house is. Lee mentioned that quick calculation that you can do if you kind of have a rough guesstimate maybe of how leaky or tight it's going to be. But we have if you go on our website under tester tools, we have the number of fans calculator. So you can use that to put in, some different metrics of the buildings. If you know the size of the building, the envelope area or the volume, it'll tell you if one fan will get you there or not. A lot of our customers that do, big commercial building tests with multiple fans use it to see how many fans they need. But you can use it for that reason too. And it'll tell you what leakage you would come at. You can adjust that leakage target as well to tell you whether if one fan's going to get you there or not. But yeah, it really just depends on how leaky the house is. You really just can't look at it by the square footage or the volume. It's why we test to figure that stuff out.
Yeah, definitely. And starting from the allowed leakage, if you have that number, gives you some kind of a benchmark to know whether your equipment would be sufficient if it's passing. And in that case, if it fails, then you could use extrapolate or something since it's a failing result anyway.
Yeah.
There's a question here. Sorry, go ahead.
Yeah, I was going to say about the extrapolation. I think and Lee, you can correct me here if I'm wrong, but you really want I'm trying to think of the best way to word this. So you kind of know that good threshold of when you can accept that reading and not. You really want the fan to be within 20% of, with it being maxed out and then where it would be if it would reach 50. So that's why I mentioned earlier, like, if you're under, 30 pascals, I wouldn't really trust it too much. But if you're over 30 pascals, you're usually going to be okay with that reading. But, that might be something that we can build into the DM32X to let you know, when you kind of cross that threshold. But Lee, if you have any insight on that, feel free to share.
Yeah, I agree with you, definitely. The further you are from the target when you use extrapolate, the more error you could potentially see, because you can get error from wind at any point, and that's going to be in your extrapolated result. So basically multiply any error you're seeing currently. Yeah, I absolutely agree with what you said.
Cool.
There's a question about which you prefer to use when you're testing a house. Do you prefer air change per hour results or CFM50?
I like CFM50. The problem that I have with air changes per hour is that it doesn't put houses of different sizes on an equal playing field. If you're looking for 3 air changes per hour, it's going to be easier to meet that on a large house than it will be on a small house. So if you're just looking at CFM50, it's kind of an even playing field. There's a group, a lot of our HVAC contractors that we talk to, they do this ratio between, and it sounds kind of like a rough guesstimate, but it's actually, somewhat accurate, is by looking at the CFM50 number as a ratio to the conditioned square footage of the house. So like a 1,000 square foot house with 1,000 CFM50 blower door number would be like a 1-to-1 ratio, which is kind of what we would call average. But if the CFM50 is 2,000 to a 1,000 square foot house, and it's a 2-to-1, which is like going to be a pretty leaky house. So when you're trying to put houses on an equal playing field, both of those have their flaws. The best way to do it is by looking at envelope area, that's how we look at commercial buildings. So if instead of looking at the volume, you're looking at the surface area of the entire envelope. So a lot of our standards for commercial buildings look for a CFM per square foot of envelope area. So like, for example, the Army Corps of Engineers, they require 0.25 CFM per square foot of envelope area. And that's really the best way to put houses on an equal playing field of all different sizes or buildings, if you're testing things other than houses. But it's just a lot more stuff to add up. So that's why ACH came into play, because it's just easier, but it has its issues. But I just like looking at that raw CFM50 number. If I have a general idea of how big that house is, and I look at the CFM50, then I can kind of tell if it's leaky or not. But that's just kind of my 2 cents on it.
Yeah, and I would definitely agree with you. Especially considering you can take that CFM 50 and calculate air change or equivalent leakage area from that number. So it's easy to work to other results if you need them. As far as instead of working backwards from air change to CFM. The
I saw Michael House just popped up and said if you send 4 guys to go get ACH up of one house, you'll likely get different answers because they're going to measure that volume in the field and probably get different volumes. So that's a really good point. It's Michael House's birthday today. Happy birthday, bud. So thanks for that input. That's a good point.
Yeah, your shirt's fitting.
Yeah, wore that just for him.
There's a question about, do you know if we're going to have a trade-in program for the DM32 to DM32X?
Probably not. Is going to be my guess. I mean, we haven't said yes or no yet, but it's just I don't really see a reason of why we would. I mean, we might decide to do something at some point, but I think we're leaning towards maybe no. If you have a competitor's gauge that you want to trade in, we might do a discount on that, but right now, I'm thinking that's probably what we're going to be leaning towards. Sorry.
And could you talk for a second about what your setup is for the for this webinar? Like what cameras are you using, and then how are you switching between them?
Yeah, I'm using the Logitech. It's called the Logitech Brio, and it's a really nice compact 4K camera. And I've got one here by my computer that you're looking at now, and this one behind me. And on Zoom, I can go where it says where I can control my video. There's like a little arrow I can press, and then that allows me to switch whichever cameras that I want. So it took me a while to get this figured out. I had a lot of trial and error with different cameras and different setups. It's important to use a USB 3.0 cable. So you want the blue when you look inside of the USB cable to make everything stream correctly. So it took me a while to figure all this out, but I finally got there. But it also doesn't like it if you pair it with another monitor. I've noticed that too. I had some lagging issues. So now when I do webinars like this and switch cameras around, I keep everything on one monitor, and it just seems to work a lot better. So hopefully that answers that.
Yeah, thank you. There's a question about testing houses that have 2 different zones and how you get pressure in that second zone. It's a little bit outside of what this webinar is covering, but
it's kind of going into some blower door 102. So in some cases, like say you have a house that has like a main zone where you can open up all the interior doors and it's all connected, but maybe there's a room that you can't access from the inside. That's when we would maybe use a second blower door to get that one to pressure. To really get a good accurate reading there. And anytime you're using more than one blower door, I always recommend using software. Let Fantastic do all those calculations for you.
Yep. And if you're Canadian, you may be aware there's another procedure for that with Hot 2000, where you're just referencing the second zone with a single fan, which if you're looking to do that, shoot me an email and I can send you some details on it. We don't support it directly in our software, but there is a way to make it happen. Yeah,
there's just room for error with that. We're just not, Lee and I have talked about this before, and we're just not a huge fan of that method, pun intended. If you can put a second fan in there just to get it to pressure, that way you're getting everything accurately in one shot. That's the best way to handle that.
Yep, definitely. Question, where's your pup at? I saw him earlier.
Oh, man.
He ran off camera.
Yeah, he's around. Here he is. Let me, I'm not sharing my camera, that camera. Everything you don't see on camera is kind of a mess. I was out last week, and then I was traveling the 2 weeks before, so I've actually been out of my office for 3 weeks until now. So, yeah, Cooley, say hi to everybody. Yeah, he's working hard. So,
yeah, very energetic.
There he is. Yeah. Cool.
Okay, yeah. I think I got everyone's questions. If I missed anyone, send them in the chat real quick, or shoot me an email, support@Retrotec, and we'll take a look at it.
Yeah, and if you haven't already, dig around through our YouTube channel too. I mean, if it's a topic, we've likely talked about it. I've had a weekly video series going on for a while, and I haven't posted one in a few weeks, called Technical Tuesdays. I think there's like 45 episodes or something where we really dive into some different stuff, where we get into the weeds on different topics. So feel free to sort through those. If you have a question, the answer is probably in there somewhere. But yeah, if you can't find something, or if you're just having trouble wrapping your head around something, you can get a hold of Lee at support@retrotec.com. And I'll share my screen here again to get through. We talked about some of this stuff. Yeah, that's my email, just sam@retrotec.com. So feel free to reach out to me too if I can answer anything for you. This is actually what I'm standing in is my office. So I'm usually working in here, and if there's something weird that you're getting, I can usually replicate it right here in the lab. I usually have a blower door set up ready to go. So yeah, if you run anything strange like that we can't really work out by just kind of some Q&A, let me know what you're doing. I can replicate it, and then we can go from there. I do that for folks all the time. So feel free to utilize us for that.
And I guess final question would be, where can people find this video?
This video, it's recorded. Once we wrap it up, I'll render it and do some edits to it, and then it'll be posted to our YouTube channel later this evening, if not definitely tomorrow morning. So if you go to YouTube, you can search Retrotec Energy and find our YouTube channel there. So it'll be the latest upload. And if you follow us on social media, we're pretty active on Instagram and Facebook. I'm active you can find me on LinkedIn as well. And we post a lot of stuff to those 3 accounts. So once it's recorded, we'll share it, and we'll be able to have the link to it that way as well. But
all right, cool.
Yeah, is that it for the question box, Lee?
I believe so.
Cool. Well, yeah, we had a really big turnout today. So thanks everyone for your interest. And if you run into some pretty cool testing stuff, or you find something interesting, email us and show it to us. That's stuff that we can, we'd be happy to share and tag your company on our social media. We love to see what you guys are up to with our equipment. There's folks out there finding some interesting things out there every day with it. And again, we're always here to help you out. So if you're running into something and just keep getting stumped, likely we've seen it before. So feel free to pick up the phone, give us a call, shoot us an email. Message us on social media too. We're usually there paying attention. So, but thanks again. We'll do another webinar on another topic later on. I mentioned the DM32X. Ben and I will probably hop on later this year too and do a webinar specifically on that. So look out for some more updates there, and we'll go ahead and call it a day. And thanks again for you guys for logging in, and we'll catch you back next time.